Hello, my name is Dr. Merritt Harlan. I'm a researcher with the United States Geological Survey, and today I'm going to be talking about accessing data from the Surface Water Ocean Topography satellite in Madagascar. This presentation is part of a series of trainings in collaboration between the U.S. Geological Survey and the Institute and Observatory of Geophysics in Antananarivo, and I would like to thank Dr. Johari Andriambalosin for the invitation to present to you all today. For today's talk, I'll give some background information on the Surface Water Ocean Topography satellite, and then I'm going to walk through two examples of accessing this data through different web portals, including the SWOT Viz web portal and the HydroWeb Next platform. The Surface Water Ocean Topography satellite, or SWOT, is a joint mission between NASA, the US Space Agency, and CNES, the French Space Agency. The satellite is designed to monitor both ocean waters, including ocean heights and waves, as well as inland waters, including rivers, lakes, reservoirs, and wetlands. Inland water measurements include water elevations, as well as widths and areas. These two sets of data allow us to then derive information on river slope, as well as volumetric changes, including river discharge and lake storage change. The SWOT satellite is depicted here, and it uses a wide swath Ka band radar interferometer to estimate these elevations and extents. What's unique about SWOT is this technology that allows us to measure elevations not only on one section of a lake or a river, but throughout the full water body. And by measuring elevations at multiple points of a water body, we're able to average that data together to get at more accurate elevation and area estimates. As I mentioned, SWOT uses this wide swath radar to measure surface water. And because SWOT uses radar technology, it can measure water bodies even when there's inclement weather, such as rain or clouds. The majority of SWOT elevations are expected to be accurate within 10 to 25 centimeters for large water bodies, which include rivers wider than 50 meters, or lakes with areas greater than 0.0625 square kilometers. SWOT does represent new technology, and data quality is expected to improve over time. However, it is important to pay attention to data quality flags, which help characterize the data and give a sense of whether they might meet these accuracy requirements of within 10 to 25 centimeters. SWOT is a global mission with data availability beginning in March of 2023. The orbital repeat for the SWOT satellite is every 21 days. However, most lakes and rivers have on average of 2 to 3 visits within this 21-day cycle. In Madagascar specifically, SWOT is measuring 7,714 lakes on average and around 20,000 kilometers of rivers, which is greatly increasing the number of water bodies we're able to monitor. If we zoom into SWOT coverage in different parts of the country, we see SWOT polygons are outlined in this light blue color, and it's measuring the Ikupa River near Antananarivo, as well as several lakes in the vicinity. If we look at Betsiboka, we see the muddy channels of the river being observed by SWOT, as well as several lakes. And in the south too, we see river coverage from the satellite, as well as various lakes in the area. SWOT measured water features include lake and reservoir data, as well as a river reach product. SWOT reaches are segments of the river center line broken up on average every 10 kilometers and are defined in order to have consistent boundaries for estimating river slope as well as river discharge. The river node product further breaks down these reach center lines into points along the center lines based on average every 200 meters, The node level product aggregates less data than the reach product, but allows us to look at changing elevation up and down the river. Now I'll transition to demonstrating the SWOT Viz data portal. SWOT Viz is developed by Quasi, an organization made up of universities allied for water research, and it uses the Hydrochron application programming interface to take data from the Surface Water Ocean Topography satellite and easily render it as features that can be viewed in a time series format. So now we'll transition to demonstrating this website. Here's the SWOT Viz web portal, and we can search for a location, for example, Madagascar, and we can also zoom in on the map. Here I'm going to zoom in to the Ikupa River north of Antananarivo, and I'm going to click on a river reach that we see displayed on the site here. And automatically metadata on this river reach pops up, and so we can see the longitude and latitude as well as the river reach ID given by this value here. And each of these metadata fields have information or an explanation on their meaning. We can view additional metadata that might be of interest. In order to access the SWOT data for this reach, we can click on this plot button, and it will query SWOT data and visualize it here for us. So automatically the time range is set to a couple of months, but we're going to go back and look at all of the SWOT data available. SWOT data is typically available starting at the earliest of March in 2023, and we'll do up to present. Here we'll see that the time series bounces up and down quite a bit, and that a lot of these dates are associated with this orange degraded data. So we're going to go ahead and toggle off those degraded values and just look at good and suspect data quality information, as these two sets of data are more likely to be accurate within that 10 to 25 centimeter range. So here we see a time series of water surface elevation over time from August 2023 up until present. And we can hover over these dates to see the actual data values. One thing I'll point out is that all of the data at this time are more or less suspect. There's very few good measurements, but most of the data we're looking at here is from SWOT version C data, but forthcoming version D data is expected to be reprocessed to be more accurate, and we might see more data being classified as good, for example, then. If we wanted to download this data, we can go to this Actions tab and download the chart, which would give us this plot. And we can also download the comma-separated values, or CSV, if we want to access that data directly. Here we're looking at water surface elevation versus time. We can also look at water surface area over time, as well as width over time and slope over time. Here I'm viewing the river reach level data, but if I want to view the node profile, we can click on this tab, and here we'll see the changes up and down the reach. So instead of having time on this x-axis, now we have the distance to outlet, or the distance in meters to the river outlet. These values are somewhat arbitrary depending on how close the river is to its outlet, but in general we see values going from higher elevations to lower elevations as we move downstream. These node profiles allow us to study the slope of the river as well as changes to the slope. I also wanted to highlight that there's a series of notebooks put out by this site that include digging deeper into SWOT discharge estimates, or further into these longitudinal profiles I just showed with the node data that you might find of use to. There's also an About page that has a lot of information on the SWOT data products, the Hydrocon application programming interface, as well as the different types of SWOT data that we're viewing here. Now if we go back to the map, let's select a different river to look at. So this time I'll click on a river in the north, the Mahavavi, and to plot the data again, we'll click on this plot sign, and it will use the Hydrocon API to query this data. And here again, we'll look at reach average data across the full time series, and we'll only look at good and suspect data. Although in this case, the degraded data does look slightly more reasonable. So here we see a jump in elevation around May of 2024, and then the water level going back down again. And again, we can look at the node profile of this river to see the changes in slope and download the data here. I wanted to highlight that here I've only clicked on 2 different rivers, but all of these lines in blue should have SWOT data associated with them, which is really exciting, and you can look at data over Madagascar or anywhere else in the world. One feature that will be added in the future to the site is the ability to also download lake data in this fashion. And next I'll transition to talking more about HydroWeb Next. Next, I would like to demonstrate another public data portal, the HydroWeb Next. HydroWeb Next has a lot of functionality. Today, I'll mostly just be focusing on accessing SWOT data through this site. There's also an in-depth tutorial guide, which I've pasted here, that goes into more detail on all of the functionality within the site. Here's the HydroWeb Next platform. We'll start by first logging in. And I have already created an account, so I'm going to sign in. But if you are a new user, you can register here at this link. We can also view data without creating an account, but creating an account allows us to then download the data and get notified when it is ready to view. So we'll first start by creating a new project. And we can add layers to this project, and we'll zoom on in to Madagascar. And if we click this Where button, we're going to look for results within our map view here. And this site has a ton of different satellite data products and in situ data products, which I encourage you to check out. Today we're going to focus on the SWOT data, but there's a lot of different water level data, or for example Sentinel-3 lake water level, and all sorts of other products that are available to view. So we're going to start by looking at the SWOT prior river database, and so we're going to add this to our project, and we can see the rivers over Madagascar that SWOT is observing pop up in light blue. We can also add the SWOT prior lake database, which shows us which lakes SWOT is observing as well. And these 2 data sets merely show us where SWOT is looking for rivers and lakes that are wide enough to be observed. But in order to get the time series information, we're going to look for the SWOT level 2 high rate lake single pass, and in this case we'll look at the prior data, as these lake data are affiliated with the prior lake database. If we're interested in lake products that might not be defined in the prior lake database, we'll then look to the unassigned. So I'm going to add the lake single pass prior data to the project, and now we can see different lakes pop up. And if we click on a lake, we can get an estimate of the water surface elevation, and we can also plot the water surface elevation data over time. Here, if we hover over the points, we can see their values, as well as the lake ID associated with these data. If we want to download the data locally, we can press this download button to export in comma-separated values format. In addition to water surface elevation, we can also view time series of water surface area. And so in order to view that chart, we'll press the new chart button up here and look at the time series of area data. In order to view the river data, we'll search for the SWOT Level 2 HR River Single Pass Reach. And if we add this to our project, we can also see the different variables that are available, including water surface elevation, reach river width, total estimated water surface area, and water surface slope. And something that's interesting about these data is we can view them as the colors change and create these nice maps of water surface slope, for example, in Madagascar. Again, to access time series data, we'll click on a water feature and add a new chart of looking at water surface slope over time. And again, to download the data, we can press this button, and we can also zoom in to a certain chunk of time that we might be interested in. Now, say for example that we wanted to download river data not only for one river but over a section. In order to do that, we can go to this results tab and use this download button here. And we're going to filter to the area on the screen, and we can download a sample or the full flat size. And then in our download center, which is also accessed up here, we can look for the download data in preparation, which will give us a zipped file of these data. So that's another way to download multiple SWOT data at once, although these file sizes can be large. In future trainings, I'll walk through how to download multiple SWOT data files through an application programming interface, but this is also a great option that is fairly user-friendly as well. And again, I really encourage you all to check out all the great functionality, and don't hesitate to reach out with any questions on this site. In conclusion, SWOT is really increasing the number of lakes, reservoirs, and rivers that we can measure globally. And SWOT data are publicly accessible through these two data portals I've showed. In the future, I plan to give other trainings, including how to access SWOT data programmatically, so that if we want to download SWOT data across multiple rivers through API commands, we can do that. And please feel free to reach out or contact me with any questions or feedback or ideas for these trainings. I'd also like to point out this link to some feedback and also a short quiz based off of this training. And again, I wanted to post the links to these awesome products that are out there, as well as the tutorial for using HydroWeb. Thanks again for your attention, and hope to see you at a future training.